Hello and welcome to assignment Linear Regression, Data Cleaning, and Feature Engineering. The goal here is to apply the principles of the machine learning lifecycle by selecting a real-world data set and implementing necessary data cleaning and feature engineering steps on training a simple linear regression model to predict a continuous target variable. Uh, we will be using a housing data set for this found on Kaggle. And to start, we'll load up the data set and identify and handle any missing values um, using, imputation, removal, etc., and address any obvious outliers. I've already created the Anaconda Jupyter lab, so we're going to go from there, and looks good. So I'm just going to go line by line here. First thing you need to do is import the pandas as the data frame. Load that, and then we're going to define the file path where the actual training data is. Uh, so we run that, uh, runs. As you can see, the data is loaded. We've got the different columns, etc. Uh, this essentially does more of the same. It's just a different way of doing it. Um, tomato, tomato sort of thing. Moving on to identifying the missing values here. I guess I could just click it. So yeah, we're calculating the percentage of the missing values for every column using the missing values percent method. So go ahead and run that. I guess I don't have to run it every time you can see it, but the missing values percentage, top 20 here, as you can see, the pool QC is almost entirely missing. It doesn't tell us a lot about alleys either. This calculates the count of missing values for each column, and is another way of doing it in the percentage of missing values. This doesn't quite tell us as much though, as you can see. It kind of only goes over yard frontage. So that one wasn't as effective a way to do it. There was no like set in stone code that we were supposed to run, so I kind of took some liberties here and there, you might say. Anywho, um, next we move on to the handling of missing values via the dropping, and we'll do that by dropping or removing it. Um, it's not in the majority of rows, which is why I chose to do it this way. So we do the data frame drop rows, and then we go ahead and print the ones that need to be dropped. It confirms that. We can drop the column with too many, NANs, as you can see. So this is, again, another way of doing it because just as I did it, it was kind of, I ran into a lot of different like hiccups and things like that. And I didn't say that one way was better, so I just decided to do it both. This tells you the missing value check. Next, we address the outliers using the interquartile range method, very common method, and by creating a box plot visual diagram. Who doesn't like a good eye, uh, easy to read? I was trying to be cool with it. So feature equals sale price there. That's what we're going to name the feature. Calculating the different quartiles here and the different bounds. We run that, and as we can see, the outlier upper bound is 340,000. To get the box plot, we have to import the matplotlib and the seaborn. We did a lot of this stuff in the AD350 database class. So it's kind of cool getting to use this again. And here is the box plot, as you can see, with the different various outliers. Whoa, what's going on over here, right? But, that's good. Looks like for the most part, it's pretty good. Next, we're going to create an age of house feature, as was suggested in the instructions, to better predict the sales price. We want to do this to get a copy, right? We don't want to, mess up the data set. We enter in our X and our Y values here, and we perform a data consistency check to ensure everything's good. We're going to, do that by checking for houses that have like, a house isn't going to be negative 5 years old, right? Unless it's like Doctor Who. Like that should be a sign that there's a data entry error, most likely. I'm not going to blame anybody, right? And it did say, hey, we found something where it looks like it actually is negative. So There's the TARDIS. Ha, ha, ha. Confirming the value of new feature by checking correlation with sale price. Pretty straightforward there. The sales price and the house age should correlate with the remodel age. And as you can see, there's the correlations. The data frame now contains two features as per the assignment instructions. Next, we'll also need to split the data into training and testing sets for linear regression model training. We can import the sklearn library, which is the standard machine learning library in Python. And we can use the house age and the remodel age for the X value and the sale price for the Y value. So that's just the import statement here. And assuming we're going on the same data set, we are using this line of code here. Here are X and Y values. Next, we'll split the data using an 80-20% categoric differential there. That's all that this does right here in the data frame. I'll just go on and do it in a split. You can see the results of that here. And training the linear regression model here, I'm really shooting for 7 minutes. I might be a little over. Here's the formula to do that. And go ahead and print that when it's done. The model training is complete, as you can see. Next, we'll evaluate and create a visual for the model. So all of it is in memory now. We have to calculate the regression metrics to measure the proportion of variance in the dependent variable that is predictable from the independent variable, and use the mean squared error to measure the average squared difference between the estimated values and the actual value. We'll use the training model to predict the sales price and the test features. That just kind of breaks that down. Relying on the sklearn library again and importing NumPy, which is another great library, we'll find the R squared score and also the mean squared score there, as well as the root mean squared error, which is oftentimes easier to interpret. So here are the results of that, and this is going to create the box plot here using, again, the Seaboard and Matplotlib. And as you can see below, we have the predicted versus the actual sales price. Now, to kind of talk a little bit about this data here, a good fit here would imply that the scatter plot points cluster very tightly around the red dashed line. It means that predicted values are very close to the actual prices, which is a good thing. A poor fit would be if they're widely scattered from the line. It means it has a large average error and the features are not powerful, the features being house age and remodel age, to be a predictor of the price. So if to break that down, if it was the best predictor in the world, they'd be all these blue dots would be right on the red line. The fact that it's a little bit scattered is okay. It just shows the level of variance in using the X values of house age and remodel age to determine the Y value, the price age. We can determine bias. Oh, I'm sorry, I'm at 8 minutes. We can determine the bias if the points from a variable curve are consistently above or below in a certain area, which suggests that the linear model is too simple for the relationship between the features and the target. Oh no, I forgot about this part. We're going to run a second test case by passing new customized data points for the prediction, new home and old home. Here's just us doing that. And then we'll use the .predict method to predict the price for the custom data. And here's that. Now, this output demonstrates that the linear regression model is operational and can generate price estimates for unseen data based on relationships that are learned from the training set. So these are reasonable predictions based on the data input. It's not like a negative value or something weird like that. Well, this has been assignment. Let me go back to my other tab here. Assignment, linear regression, data cleaning, and feature engineering. Thanks for watching. Goodbye.